Plotting quadratic graphs. Learning objectives. By the end of this section you should be able to plot the graph of a quadratic in the form ax squared, plot the graph of a quadratic in the form ax squared plus bx, and plot the graph of a quadratic in the form ax squared plus bx plus c. A quadratic function produces a curved graph called a parabola. Quadratic graphs have two basic shapes: U-shaped or N-shaped. To plot a straight line we need 2 points. To plot a curve we need more points. The closer together the points are, the more accurate the graph, especially around the turning point. The coordinates of the points are generated from the equation. Plot the graph of y equals x squared. Choose values for the x coordinate, then square them to find the y coordinates. So here we have x and y. When x is 0, y is 0 squared. 0. When x is 1, y is 1 squared. 1. When x is 2, y is 2 squared. 4. When x is 3, y is 3 squared. 9. When x is 4, y is 4 squared. 16. When x is minus 1, y is minus 1 squared. 1. When x is minus 2, y is minus 2 squared. 4. When x is minus 3, y is minus 3 squared. 9. Finally, when x is minus 4, y is minus 4 squared. 16. Join the points up with a single stroke of a pencil. Never use a ruler. The graph of a quadratic is a curve. It has no straight parts in it at all. Don't ever be tempted to do it with a ruler. It doesn't make it look tidier, it makes it less accurate. And don't worry about being exactly spot on the lines. When we're drawing a graph by hand, it's only ever going to be an estimate anyway. If we wanted to be really accurate, we'd use graphing software. The values of the y coordinates in a quadratic function increase exponentially. This means that each increase is greater than the previous one. The y values can get very large very quickly. Because of this, it's a good idea to work out the coordinates before you draw the scale on the axes. If you don't, you'll work out your values and realise that the scale that you've drawn or the axes you've done are just too small to plot your points on. So here what I'd like you to do is plot the graph of y equals 2x squared and plot the graph of y equals 4x squared. So pause the video now, do that. Once you've done it, come back and press play and compare your graphs. Right, question 1. There's a graph of y equals 2x squared. What you're looking for is yours the same sort of shape. Does it take up the same area or the same regions of the graph? And for question 2, again we still have that same parabolic curve, but here it's narrower. So as long as yours looks somewhat similar to that, we'll move on. For simple equations such as 3x squared or x squared plus 4, it's possible to choose an x value, apply the function and arrive at the corresponding y value in your head. For more complex equations, this method is likely to result in errors. To avoid this, it's advisable to use a table to produce the y values. Plot the graph of y equals x squared plus 3x plus 2. Draw a table with x in the first cell. Below this, each term from the equation is entered in order. So from our equation we have x squared plus 3x plus 2. The y value goes in the bottom cell. So we choose a range of x values. This will usually be given, or at least the upper and lower values will be. Why do you think in a question you're going to be given the x values, or at least the upper and lower ones? Well, from the last exercise you should have noticed that the y values go up, as we said, exponentially. If you were free to choose them, if you went from 0, 5, 10, 20, 30, very quickly you'd have a massive graph. So by being given the range of the x values, what we're doing is we're controlling the section of the graph that you draw. So here we have the x values which are given to us, and they range from -4 to 1. Work out the value of x squared for each of these values. So -4 squared is 16, -3 squared is 9, -2 squared is 4, -1.5 squared is 2.25, -1 squared is 1, 0 squared is 0, and 1 squared is 1. Work out the value for 3x for each of the x values. So 3 times -4 is -12, 3 times -3 -9, 3 times -2 is -6, 3 times -1.5 -4.5, 3 times -1 -3, 3 times 0 0, and 3 times 1 is 3. The next term is +2, so this is entered into each cell in the next row. Add together the numbers to give the y values. Don't include the initial x value. So the top row was just our values for x. That is not part of the stuff we're adding together. So here it's just 16 -12 plus 2 gives us 6. 9 -9 plus 2 is 2. 4 -6 plus 2 is 0. 2.25 -4.5 plus 2 minus 0.25. 1 -3 plus 2, 0. 0 plus 0 plus 2 is 2. 1 plus 3 plus 2 gives us 6. If we look at the y values, you notice there's a pattern which will become apparent later on in the session. So the coordinates can now be plotted. We have -4, 6, which goes here. The next one, -3, 2, -2, 0, -1.5, minus 0.25. So you see from there, the numbers we come up are not always going to sit nicely on our lines. We could make a massive scale for this, but then again, to cover this range of numbers, it would have to be really big for us to be able to do that. So sometimes you're just going to approximate it, do it roughly where you think it fits, use a bit of judgment. Next one, minus 1, 2, 0, 2, and finally 1, 6. So join the points with a single stroke of a pencil. Again, never use a ruler. There are no straight parts in a quadratic curve. So what is the y-intercept? If you look at this, whereabouts does that graph cross the y-axis? Well, if the y-intercept is not the same value as c in the equation, the graph is incorrect. So this is an indicator, it's something we look at afterwards. Does my graph look correct? If the line is not a smooth curve, the graph is incorrect. So you have to check your working out again. And if the line is not symmetrical through the turning point, and this is what I was on about, where you say you can see the pattern in there, this graph is symmetrical. So around the turning point, the numbers going out, if the x values are evenly spaced, so will the y ones, they'll match. For each of the graphs you're about to see, state a reason why they must be incorrect. Don't want you to try and work out any values, just look at it and say what is wrong with this graph, and these are the types of things we need to be looking at once we've plotted a quadratic graph. So take a few minutes if you need it, pause the video, come back, come up with some ideas. Don't bother trying to sketch these, just make some notes. There's one thing wrong with each of these graphs. Well, graph number 1, it's not symmetrical through the turning point. It's larger on one side than it is on the other. Graph number 2, the y-intercept should be minus 2. So the c term in this equation is minus 2, yet the graph is crossing at minus 1. Graph number 3, again, it's a y-intercept. The y-intercept should be 0. Sometimes throws people out when there isn't anything there, but if there isn't anything there, the only value it could be is 0. And finally, question 4, you could have said two things on this really. The one I was trying to highlight is that it's not a smooth curve. If you'd said that it's not symmetric through the turning point, again, that would have been another reason why it wasn't accurate. So what I'd like you to do is to use the tables here, come up with the y values, and then plot the graph of y equals x squared minus 5. And question 2, again use the table, come up with some y values to plot the graph of y equals x squared plus 3x. So pause the video now, go through that, and once you've done it, come back and check your answers. So there's the table of values, and there's the graph. And again, what we're looking for here is the shape. Is it the same shape? Is it in the same sort of area on the axes as this one? And question 2, there's your table of values, and there's the graph. Right, final 2 questions for this session. So question 3, I want you to use the tables to generate the y values and plot the graph. And then for question 4, just complete the table, no need to draw a graph for it. So pause the video, go through them. Once you've done, come back and check your answers. So there's the table of values, and your graph should look something like that. And for question 4, there's your table of values. Hopefully you've all got the same. And that's it for plotting quadratic graphs. So if you have struggled with any of this, go back through it. The main thing for this is to getting the table of values right. Once you've got that, plotting the graphs, fairly basic thing which you should all be comfortable with.